Welcome, everybody. We are just getting started here. I'm going to let a couple more folks trickle into the room. Thanks for your patience as we get ourselves going on this Monday afternoon. All right, I'm going to kick us off. Hello, welcome to this month's Midwest Climate Adaptation Science Center Science Seminar. We're going to be talking about some of our newest funded projects today, so excited to get into that. But before that, just a couple of the usual housekeeping notes. This seminar is being recorded. It'll be shared out with everybody who registered and posted on our YouTube channel after this. So please keep yourself muted when you're not asking a question, and you can choose to have your video off while our presenters are sharing, and then turn it on for the Q&A at the end of today's seminar. Speaking of which, you are welcome to raise your hand or put questions in the chat throughout the seminar today, but we will have dedicated Q&A time after all of our presenters share about their projects. So don't worry, there will be plenty of time to ask questions, and I hope that you do. I can introduce myself. So my name is Jess Delfiaco. I'm the communications manager for the Midwest CASC, based here at our host institution of the University of Minnesota, Twin Cities. And many of you have probably seen this graphic before. Just a quick overview of who we are. So the Midwest CASC is a partnership between the US Geological Survey and a consortium of 9 institutions in the Midwest region. We are part of a national network of these climate adaptation science centers, all of which work to produce science that can inform resource management efforts and help fish, wildlife, water, land, and people adapt to a changing climate. We accomplish this mission together in several ways. We conduct synthesis, the Midwest CASC Consortium conducts synthesis research on topics that are relevant to regional priorities and have national application. We support a network of affiliated graduate students, postdoctoral fellows, as well as a undergraduate research experience hosted by the College of Menominee Nation in the summertime. We host capacity building workshops and events events like these seminars, as well as our annual gathering. And then lastly, of course, the USGS funds through the Climate Adaptation Science Center's adaptation research projects and partnerships, which you will be hearing about today. I'm going to hand it over to Alyssa for a couple announcements about current events.
Hey all, I'm Alyssa Welch. I am the program manager for the Midwest CASC Consortium based in the Twin Cities at the University of Minnesota. A couple announcements here today. One, we are continuing our outreach about our Midwest CASC Small Research Projects Opportunity. This is a consortium activity that is aiming to fund research activities and relationship building activities, research relationship activities that have a high potential to inspire, promote collaborative, decision relevant research now or in the future. The focus for these projects is co-produced science that is meeting a tribal adaptation need or concern, putting tribes in a leadership position on these projects as primary PIs, co-PIs on the research being proposed. This is a scope of work format that is meant to be a small research project opportunity. It is not affiliated with the formal USGS annual solicitation. It'll be a scope of work submitted to University of Minnesota as the host of the consortium. And it is a non-competitive opportunity. So if you navigate over there to that URL, check it out for more information and or email me if you've got questions. We're really excited to be offering this opportunity out as a way to grow consortium connections for research in the region. Next slide. Also going on right now, we are, USGS is hiring an ORISE fellow to work with the Midwest CASC and the National Park Service on climate adaptation infrastructure management for the national park system in the Midwest. apply by November 22nd. I think I'm sure this also just showed up in the email newsletter that Jess sent out this morning. If you are not on the email newsletter, you want to be. So you can also find information about that on our website. Thanks, Jess.
Yeah. Desi, are you with us? Do you want to?
I am here.
All right,
Yeah.
great.
Thanks. We had a little bit of technical issues earlier, but I am here and very, very happy to be with you all today. Welcome, everyone. My name is Desi Robertson, and I am the research coordinator for the Midwest CASC. I am really excited today to be introducing you all to some of our project leads for our FY24 project solicitation. We have 5 great projects. Before I jump into introducing the teams, I just want to give you a quick rundown of the numbers from our fiscal year 24 solicitation. So we received 31 statements of interest requesting nearly $12 million in funding. And of those 31, we invited 10 full proposals requesting about $3.8 million. And of those 10, we have awarded 5 of those proposals for funding. And so these projects are total about $1.7 million in funding. We are in the middle of our FY25 solicitation, so certainly more exciting science still to come to the Midwest CASC. Now, for today's seminar, we have 5 presenters, and I'm going to introduce each speaker, and then I'll pass it over to them so they can share about their project. We have a couple of slides for each project, and I'll ask each PI to introduce themselves, their teams, as well as some of their partners, and just give an overview of what they expect to come out of the project. We do hope that this is a bit of a meet and greet. So PIs, we want you to give us your excitement about your project and your plans. We have reserved some time for questions after all the speakers have gone. But please, if you think of any questions while somebody is speaking, go ahead and drop them into the chat. And we can try to get to all those at the end. So without further ado, since I have talked enough and we want to hear from all of our great speakers, I will go ahead and introduce our first speaker, who is Ryan Berner. So Ryan is a research biologist at the USGS Upper Midwest Environmental Sciences Center in La Crosse, Wisconsin. Ryan's research combines field studies and Bayesian modeling of a range of taxa from around the world. And his project is titled Climate-Driven Changes to Forested Wetland Hydrology and Inundation Dynamics, Implications for Breeding Frogs as Indicators of Ecosystem Health. Ryan, take it away.
Thanks, Desi, and thanks, Jess, and thanks all of you for being here. So as she said, I'm Ryan Berner at USGS in Wisconsin, and really want to shout out to my co-PI, Jeff Riley, who's in the Southeast region, also with USGS. And as you'll see, is going to be most of the brains behind what we're going to do. But water, of course, no one has to tell us, is an important resource for humans and for ecosystems in general, not just species, but kind of all the natural processes that are going on. And climate is obviously going to have a big impact on water, but it's also tough to predict how this is going to play out in different bodies of water. And if we think about rivers, for example, there's a lot of river data out there, river sensors that USGS and others operate. And so there have been some fairly successful modeling attempts in the US at predicting water flow under different scenarios in rivers. If we go to wetlands, it gets a little tougher, but there have also been some successful efforts in recent years looking at wetlands, especially non-forested wetlands, where you can do some remote sensing and figure out where the water's at, and then at a given time, and then build some models. What has been really tough are these forested wetlands like we have in the forested parts of Minnesota, in Wisconsin, and in Michigan, and of course, many other places. And figuring out what's going to happen with these, because you can't really see them from the sky. There's not necessarily even great databases of where they all are. And so that's what we're interested in. And that's what partners in the region, the Fish and Wildlife Service, Park Service, departments of natural resources in the various states, and then the Midwest partners for amphibian and reptile conservation. Some of our partners are interested in what this means, what climate change will mean for these forested wetlands, and what that will mean for reptiles and amphibians. And so my colleague Jeff Riley has a nice data set from the Southeast and has recently published a paper where he used machine learning methods to pretty successfully model water levels in some forested ephemeral wetlands there, or rather to model kind of inundation as a binary response. And we, fortunately, because of my predecessor and one of my coworkers here in Wisconsin, have this long-term kind of 15 to 20-year data set of water levels from forested ephemeral wetlands across the region. And so we're going to bring that data set and kind of collide it with Jeff's method to predict wetland inundation status back across all these years with different climate in different areas that we've got data for, and then use that to project under future scenarios to those wetlands and hopefully to some additional wetlands as well that are of interest to partners. And then that's kind of where I come in as the frog guy on the project, where we already know something about the duration that most of the frog and amphibian species need to kind of get from eggs to metamorphosis. So we know they need a hydro period that long. We're also going to do some modeling to try to figure out how the timing of that might shift. And then we can match what we learned there up with these model predictions for the wetlands of interest and kind of determine under what scenarios are which species going to and not going to have enough time to get through a full breeding cycle. And that's the goal. And Jeff has already made good progress on the wetland modeling part. But if anyone is aware of data sets, whether it's water levels or even just wet dry status on known days of the year for any forested wetlands in this region, we would love to continue expanding our data set. So thanks, and look forward to the other speakers and the discussion. Yes, and so we have another slide, and this just illustrates a bit of what the modeling is doing. So here on the left is our raw water depth sensors from 2 different wetlands, and you can see they go through several drying periods in this particular season. And then on the right is what the model predictions look like for the full machine learning model that's been fitted to that data. And you can see it's these binary predictions of wet, dry that match up pretty well with what we're seeing. And then once we have that, there's, you can think about a wood frog in each of these and about 140 plus days that it needs to go through its full cycle. Don't quote me on that number. You can see 81 days here in the blue wetland was not enough for that wood frog. It's drying several times in there, but in that red colored wetland, it was enough time for that full annual cycle. And we would say, well, that's probably an opportunity for successful breeding. So that's the general idea presented visually. Thank you.
That's great, Ryan. Thank you so much. I love vernal pools and critical habitat for so many species. It'll be really interesting to see how this machine learning approach leads to kind of better understanding of those systems. As Ryan mentioned, if you have any data sets that might be of use, please reach out to Ryan. I'm sure he'll appreciate that. Okay, our next speaker is Corbin Hilling. Corbin is a research fish biologist at the USGS Great Lakes Science Center's Lake Erie Biological Station. He leads the Great Lakes Science Center's grass carp early life history research, and his project is titled, "Does Less Ice Cover Lead to More Turbulent Overwinter Conditions on Great Lakes Fish Spawning Reefs?" Corbin, I'll pass it on to you.
Thank you. Can you hear me okay? Okay. I was having some audio issues earlier. So this project is kind of focused on lake whitefish and cisco, which have provided very large fisheries in the Great Lakes. For a long time, they've since declined in part due to the combination of effects of invasive species, habitat loss, and overharvest. In fact, in Lake Erie, Cisco were believed to be extirpated, although a few records have popped up recently, possible fish that have come down from Lake Huron. And part of it is related to recruitment. And so ice cover has been linked to recruitment as an important factor that could influence year-to-year reproductive success. But the mechanism for that's been kind of hypothesized, but not really confirmed. And so there are several hypotheses that exist. One is that ice cover shelters spawning reefs from overwinter waves and circulation. It's thought that those currents and waves could displace eggs from those preferred spawning reefs. Lake whitefish and Cisco spawn in the late fall around Thanksgiving, and then the eggs are there over winter to develop. So the overwinter period is critical for recruitment success. And so we're working with the Lake Erie Committee, Habitat Task Group, Ohio DNR, and I'm a fish biologist, so this is getting more into the oceanography realm, which is not where I have a ton of expertise. So I'm working with oceanography engineering experts from Purdue and University of Minnesota Duluth. And to kind of give you a little schematic on what's going on here, can you go to the next slide, Desi? This is poor planning on my part, but I have a bunch of animations here. Thank you. So fish are going to come in here pretty soon. They spawn around November. They're going to lay their eggs on the spawning reefs. You can go ahead and go to the next. The adults leave. The eggs are still there. Again, they're gonna develop over the winter. And so we're going to drop some acoustics equipment on the bottom of the lake near the reefs. And we're going to collect data over the winter. That's sound. So the devices use the Doppler effect to get at water speed. We're going to measure average current velocity, turbulence, wave height, ice cover, ice thickness, and the movement of ice as well. And all of this is going to give us an idea of what the water's doing when there's ice cover and when there's not, which is going to help us understand what an ice-free winter looks like for these eggs as they're developing and hatching and being larvae. The idea here is, again, that without ice cover, they're displaced. They're either damaged due to wave stress or displaced from the reefs. And I think there's one more animation, and so we're going to do this with and without ice cover to look at those two conditions. Hopefully we get a good ice year. We have 2 field seasons to hopefully get some ice, but that's the overall field component of the research. And then we're also going to look at where in Lake Erie specifically might be areas of possible adaptation-driven restoration efforts where some reefs may need some augmentation or enhancement to make them more suitable for future recruitment in the conditions that we have less ice cover. And I think that's about it. And thank you.
Thank you so much, Corbin. Those animations were great. Look like little spaceships landing on the bottom there. Looking forward to that work. Okay, our next speaker is Famara Dampa. Famara is a research scientist in natural capital and ecosystem services at the University of Minnesota's Institute on the Environment. He serves on the Natural Capital Project, also known as NatCap, leadership team, where he catalyzes the University of Minnesota and INE community of faculty, staff, and students towards high-impact interdisciplinary research with the National Capital. And his project is titled Nature's Value in Reducing Flood Risk Impacts in the Upper Mississippi River Basin. Thank you. Famara, take it away.
Well, thank you very much, Daisy, for that very kind introduction. Yes, I'm coming into this from an interdisciplinary perspective, but also as a natural resource scientist. Our project, which is really a team of about 7 to 8 people working on this project and different components of it, The idea here is to assess nature's value in contributing to reducing flood risk across the upper Mississippi. And then it has these three components, and I have to give shout out to Jessica for putting these slides together, because you clearly articulated the main points about this project. So the first one is to do an assessment, and there we're looking at which is what we know as component one, is to look at flood risk assessment, and this is current and projected flood risk. And then flood risk there, note that it's not just flood hazard, but it's risk as a function of three components or subcomponents. So you have the hazard layer, the hazard exposure layer, you have the vulnerability component, and then the capacity or its lack of. So these are very important components when it comes to the flood modeling approach that we are doing. And then we're using the informed risk index approach, which is developed by the European Union's Joint Research Center. And then the second component is where the project that Des mentioned, this natural capital project, we want to assess what is nature's contribution. So we're thinking of developing an ecosystem service index specifically for what? For flood risk reduction. So there are a lot of different ecosystem services that we know can contribute to reducing flood risk. You know, you think about infiltration capacity in certain places that have more nature-based solution is higher than in other places. So we're working on different, and there we're using INVEST models. So INVEST is integrated valuation of ecosystem service and trade-offs. So there are a lot of different models that we are playing with there. And then the last component is this idea of dialogue and knowledge exchange with our community partner as we develop the modeling approach. So for example, we've scheduled our first, what we call our community knowledge exchange checkpoint meeting that is coming on December 5th, where we're going to have dialogue with our community partners and other stakeholders that are working in the upper Mississippi Basin to basically say, here are our modeling approaches. These are the data sources we're using. You know a better data source, and how can we learn from the experiences that other people have done? So we are actually reaching out to other projects that we are funded by, for example, the Southeast CASC. They did a really wonderful flood risk modeling across the US, and we're talking with them, I think, tomorrow specifically to, again, build on these existing projects and existing data layers. So if you go to the next slide, there might be so here is the concept, right? So what we're doing here, you know that the upper basin is, it's rated C by the American Watershed Initiative. So, I mean, all of the watershed across the basin, not just the upper, has very low gradient there, but it's important that for us, we are looking at this hotspot mapping, and these are just some preliminary findings that we are getting based on the data sources that we're using. So when it comes to the hazard layer, that is not incorporated into the map that you see. So the current and projected flood risk map for that hazard layer is not added here. But what you see here is basically two existing components. So one is the CDC vulnerability index, and then the second is this baseline resilience indicator for communities that is developed by the University of South Carolina. And so the idea of our modeling would be to combine these different data sets, but in a way that makes sense using the informed risk framework. So think of risk as a function of your hazard exposure, your vulnerability, and coping capacity, or its lack of. So what is our coping capacity or its lack of in this scenario here would be these baseline indicators on resilience, which according to FEMA is actually the best index that is developed across all of the different indices that are developed around community resilience to deal with flood and other climate-related hazards. There is another one that FEMA itself developed, is called the community resilience challenge index. But even compared to this one, FEMA recommends using this indicator specifically. So our initial idea was that if there are no existing indicators that are suitable for this project, we will use indicators instead of indices. So we'll use indicators to build our index. But I think what we are finding from the literature, there are really very well established indicators and indices that we will take advantage of in 5 months in this project. So I think this may be my last slide. I'm happy to take any questions, and I'm happy to give details on, say, what is in the CDC vulnerability index if people are curious, and specifically also on the resilience indicators. So thank you very much.
Great. Thank you so much, Famara. Really great project, a lot of great partnerships, and love that interdisciplinary work. Okay, our next project is PI is Ben Zuckerberg. And Ben is a professor in the Department of Forest and Wildlife Ecology at the University of Wisconsin-Madison. His research focuses on studying the impact of climate change on wildlife. And his project today that he's going to be talking about is identifying past and future climate change refugia for Midwestern birds. I'll turn it over to you now, Ben. Thanks.
Great. Thanks, Desi. Yeah, and as Desi just noted, our lab really focuses on this idea of modern climate change and how it's impacting wildlife populations, and in particular, what can we do in terms of climate change adaptation on the ground to help buffer those species from those impacts. And so I think we can all agree that birds are one of the more important sort of groups and sentinels of climate change. And certainly what we've seen over the last 40 to 50 years has been many of these species are shifting both their ranges and their phenology in response to climate change. And in particular, in terms of their shifting ranges, many of these species have been moving northward or shifting their elevational range boundaries in response to climate change, warming, and shift in precipitation. And so really what our broader goal is to look at some of these long-term range shifts and to identify which species are potentially most impacted by climate change. And this has been done in various degrees for different regions, for different species. But part of what we hope to address in sort of a more holistic way is to be able to evaluate the role of protected areas in mediating some of these dynamics, both in terms of the colonization and extinction dynamics that may be playing out for individual populations and species. So I think, as we all know, that there are a lot of climate change adaptation practices and principles out there, but certainly one of the most widely touted strategies and actions is this idea of protected areas. But obviously, protected areas tend to be relatively stationary, and yet most of these species are shifting relatively rapidly over the last 30 to 40 years. And in doing so, part of our sort of mission here is to try and understand, are these protected areas still serving the role that they were meant to serve? And so to answer this question, what we really want to do is model climate suitability under sort of both historic and future climate and land use scenarios, and really try to get a sense of whether or not these protected areas are mediating some of these range dynamics. So there's a fair amount of, I'd say, debate a little bit in the scientific literature about the role of protected areas. Are they serving as sort of these holdouts or refugia for certain species, or are they serving as stepping stones in terms of those species that are shifting their ranges? And so that's what we would like to kind of evaluate, is to see whether or not these protected areas are in fact serving this role of refugia. Are they doing it for certain species or groups of species? And in other cases, for species that may be expanding their ranges, are they in one form or another serving as these stepping stones that are mediating these expansion dynamics? So part of what we like to also do is kind of look at individual areas, protected areas, and be able to actually give a portfolio of the species that have been there historically, they're currently, and what we project to see in terms of the change in that assemblage over the next 50 years or so in terms of climate change. So in terms of our broader question, we really do, in talking with our group of partners, that there is sort of this urgent gap and sort of data gap in evaluating sort of the long-term success of these protected areas and really seeing whether or not protected areas as a climate change adaptation strategy is kind of holding true and holding fast given this sort of rapid environmental change. It's been sort of a long time coming in the sense that we've had this partner group that's been really thinking about these questions for some time now. And I'd just like to identify them at this moment that we have great representatives from the Forest Service, from all 3 DNRs from Minnesota, Michigan, as well as Wisconsin, the Audubon Society, the Nature Conservancy, and our other partner, because I'll kind of talk a little bit more about this, we are kind of bringing to bear a bunch of different data sets to kind of model these dynamics. What I would say is that all of our partners in one form or another, especially the agencies, do protected area, both delineation and management in very different ways. And so part of another question is what makes a protected area particularly effective in terms of its connectivity, its size, and so forth. So we can move on to the next slide there, Desi. Yeah, great. So I just want to kind of sort of bring to bear that this kind of is meant to be sort of a cycle. Basically sort of this idea, this approach of being able to think about what the questions that our partners have in terms of these information gaps. And so we solicited these questions from our partners, and these are the ones that we will hopefully be able to address, which is sort of what are some of the causes of these range shifts in terms of which climate components may be really driving them, which species might be most vulnerable, are there certain biodiversity hotspots that may be changing, are there certain protected areas that may be serving as refugia, what makes a protected area particularly effective, and can we inform sort of future monitoring efforts? The other kind of question that we have is that even though we may be doing this at a very individual species level, part of what we are hoping to do also is be able to look at how these community shifts are happening and composition of these bird communities may be shifting over time. There's a process that we generally call thermophilization, this idea that warm adapted species are beginning to dominate certain communities. And are we seeing that process play out in certain protected areas compared to other ones? We kind of are going to bring everything to bear in terms of this integrated species distribution modeling approach. We're using breeding bird survey data, bird atlas data, eBird data. All these data sets are obviously really powerful data sets. All of them have certain challenges in working with them to address this question. Some of them and all of them have important strengths. And so the idea is if we're looking at all these data sets, we can effectively leverage all those different strengths. What we hope to produce are this sort of past and future maps of species occurrences, thinking about these future community shifts, both in terms of sort of biodiversity, but also functional diversity across these species, and really to help inform climate-informed planning. And I keep using this word protected areas, but this really represents a whole diversity and different gradient of protection from state natural areas, conservation opportunity areas, Forest Service lands, important bird areas, resilient landscapes for the TNC. And so we are hoping to address in one way or another kind of the effectiveness of all these different approaches in being able to mediate these range shifts and range dynamics for these different species.
Thanks, Penn. That's really, really great. Looking forward to this project. Interesting to think about protected areas and these implications. And, as a former parkie and thinking about how the goals are to, preserve and protect and how the reality of that is going to be in the future. Thanks.
Absolutely. Thanks, Debbie.
Okay, our final speaker, last but not least, is Kristen Ellis. Kristen is a research ecologist with the USGS Northern Prairie Wildlife Research Center in Jamestown, North Dakota. Her research is focused on migratory bird ecology and developing quantitative and geospatial tools for addressing conservation issues. Her project is titled Relieving the Sting, Spatial Prioritization for Pollinator Conservation Under a Changing Climate. Take it away, Kristen.
Hello. So I'm excited to be here and be talking about our new study focusing on how climate change may impact the distribution and occupancy of the endangered rusty patch bumblebee. So first, I just want to highlight the partners that are listed on this slide, as well as co-PIs. That includes Clint Otto and Audrey Lofspeech from Northern Prairie Wildlife Research Center and Ralph Grundell with the Great Lakes Science Center. So this species historically was abundant and widespread across much of the central and eastern US and southern Canada. And then since the 1990s, their distributions have really shrunk to just tiny pockets of their historical extent. So because of these declines, the species was listed as endangered and was the first bee species to receive federal protection. Through some of our ongoing studies on the species, we have found evidence suggesting that local extinction probabilities are greater during periods of drought, meaning that sites that were previously occupied becoming unoccupied following prolonged drought conditions. So for this project, we plan to evaluate a suite of weather and climate factors that may influence rusty patch bumblebee occupancy dynamics, and then use these models to project distributions and occupancy under future climate scenarios. Then these predictions can be used to identify priority areas for conservation under climate change uncertainty. And then we also plan on developing a web tool for our partners to use our results to target areas that may be candidates for conservation action, such as reintroductions or habitat enhancements. And then go to the next slide. Just a little bit more background on our ongoing work. This study region includes these 4 states in the upper Midwest, and these grids are 10 by 10 survey grids that was created by the US Fish and Wildlife Service to record where and when rusty patch bumblebees have been observed. So we're working with the US Fish and Wildlife, and they manage a really large presence-only database of rusty patch detections. So because it's a presence-only database, there's no information on where people have looked but have not seen the species, and that missing information is really critical for evaluating trends of occupancy and species distribution across time, and for evaluating their recovery targets. So what we plan to do is gather monitoring data for common bumblebee species from multiple sources, including iNaturalist, Bumblebee Watch, the Wisconsin Bumblebee Brigade, and others. And then this additional data can provide us with the information on where people have been conducting bumblebee surveys but have not detected rusty patch. And our project partners are interested in improving and standardizing their monitoring techniques, and then applying these same statistical tools for other imperiled pollinator species. Thanks.
Great. Thank you so much, Kristen. I think I loved your title, the best. It's that's a stingingly clever title, and I don't know that I didn't pull that off very well. But really looking forward to this project, and especially with our poor rusty patch bumblebees in decline and not doing as well. So looking forward to learning more about that one. Okay, well, that sums up our 5 speakers that we have today. We have